I'm part of solutions team, and as a part of solution team, we work with a lot of solutions regarding different domains. So the solution that I'm going to discuss today, it is an AI based. So before starting, I want you guys to take a moment and think of all the activities you guys have done from the time you have woken up, and all the data that those activities would have generated. Just to give you an example, we might have scrolled Instagram or social media. We would have taken a ride using Ola or Uber to come here. We would have done some transactions. We would have taken snaps, shared with our friends and family. All these activities generate data. Some of the data is structured data, like transaction details or ride details, whereas some of the data is unstructured, like images. Here, our topic is text to SQL. So mostly we'll focus on the structured data. So as the structured data grows, we want to take information, we want to fetch information out of it. We want to analyze the data. So for the same, we want to store the structured data in a way that can be easily retrieved. For the same purpose, we store it in a structured database, which is relational databases. Now, because of the same reason, as the growth of the structured data is increasing, the relational databases are also growing. The chart here shows the same. The numbers representing here, they are in billions of dollars. It clearly shows that companies, they are ready to invest in relational databases because they see the value in taking data-informed decisions. Now, so in order to take these decisions from the databases, we need to know SQL, structured query language. So structured query language, being a programming language, it has its own structure and rules. A non-technical person who is looking into business side may not have the knowledge to build simple to complex queries. In this case, they may depend on the data teams. They may depend on other technical teams in order to fetch the metrics that they want to analyze, in order to see what is going on in the market. This creates a dependency on the data teams. As well as even for data teams, they get these demands from different other teams. So it creates an overhead, which in a way is a delay in the decision-making process. And as we all know that insights delayed are the opportunities lost. And as a company, I don't want to lose those opportunities. So there is a need here to automate the generation of SQL. This is what we'll look into. So here, we have built a system which will take the query in English language. It will convert the query in the backend, it will convert the English language query into SQL, and then it will execute this SQL into the database. In a way, as a user, I will be asking a question in a text in English language as a natural question like in the English that we use, and I will be directly getting the answer instead of not knowing anything about SQL. This is how we are automating the text to SQL. The SQL generation query automation. Now let's see how it will impact business. So as we have discussed that earlier, for non-technical people, it created a dependency on the data team. So by automating this SQL generation process, we are eliminating the dependency on the data team. That's why it will enable faster decision making. It will also increase accessibility to teams, accessibility of data to teams. Because earlier, if I want to write a SQL query, I should know what the data is. What are the tables, what are the exact name of the tables in the database, what are the columns those databases have. And if I don't have that information, I won't be able to write the query. So the data is not that accessible to me. Now, by automating this process, I can ask question and I can see that now I can get whatever data I want to. So this automation, it makes the data accessible to different teams. It reduces the wait times. And also, if you present this solution as a chatbot to your customer, where they can also see the queries or the metrics which are related to them, it will also enhance the customer experience. So yeah, now let's see how we can build this problem, how we can build this solution. So as we know that we are living in an AI era where Google queries, they are basically getting replaced with GPT searches. Anytime we have a problem or we have something to automate or we have something to write code for, we go to GPT often and then we ask our question and we get the answer. And mostly those codes and all, they work. Similar thing we did here. When we first thought about that we need to have a system that can automate the query generation process, we went to GPT and then we asked whatever question we wanted to. So here, as an example, we asked, show me the total sales amount for customers in New York in last 3 months. So that GPT also knows what are the columns and tables, we also gave database schema. And then it gave the SQL query. Everything was fine, and then we copied this SQL query, we ran into a database, and it was working. So it seems that the problem is simple. But there are a lot of issues that can arise in this approach. I want all of you guys to think and tell me, like, if you think what can be the issue just by directly using LLMs and giving all our data in the form of database and asking the question. So what if you have large databases where you have multiple tables? In that case, the schema will increase. The schema will become more complex. As we know that LLMs, they input the data in the form of tokens. And as the database will grow, these token number will also grow. And for each token, we have some cost associated with it. That will increase the computational cost. As well as these LLMs, they have a limit for input and output tokens. And as we'll hit this limit, we will get the error as it is being shown in the slide, that context length exceeded. So we cannot use it. We cannot use this solution directly because it is not scalable. It works very well with small databases, but it doesn't work well when the database size grows. It also, when the database size increases, the number of tokens will increase that we don't want because of the computational cost. The latency will increase because there is now more data to process, and it will also include expensive API cost. Now to solve this problem, we introduced RAG approach. So RAG is there in the AI market from very long time, and I'm sure we would have built a lot of solutions using RAG. So here also we thought, like, why not to try this? So before explaining further, just just understand what RAG is. So RAG is retrieval augmented generation, where it's a system where you store your data in the form of vectors in vector databases. You have LLMs. Whenever a user asks a query, that query first goes to the vector database. On a high level, you search the relevant, retrieve the relevant content from the vector database according to your query. You give just that relevant content to your LLM, and then LLM generates the answer from that content. In this way, you are reducing the search space. You are not giving the entire data to the LLM, you are only giving whatever is relevant to your query. So that's what we thought of doing here also. We embedded the database schema in a vector database. This database schema had table names, table description, column names, column description, their relationships, etc. Now, once we embedded, based on the user query, we said the most relevant tables and columns were fetched, and then LLM created the SQL query using those relevant tables and columns. So now in this case, LLM is only dealing with relevant tables and columns, not with the complete database. So yeah, so let's understand the problem using an example. I have a furniture store company. I am storing my structured data in a relational database. I have huge database. Out of this database, there are some tables like customer, where I'm storing the customer demographic information. I have a table orders, where I'm storing what the customer have ordered, let's say what products they have ordered, how many units of those products they have ordered. And I have another table called payments, where I'm storing how much they have, how much on an aggregated level customers have spent, and what payment modes they have used, etc. Now I have all these three tables majorly, and other than this, other tables also. I use the RAG approach. I ask this query, show me the total revenue from customer age 25 to 35 in the last quarter. In the RAG approach, first, this query will go to the vector database, where I have already embedded my database schema. It will try to fetch the relevant tables and columns. What if I don't have a table with a name or a column with a name total revenue? What if my column names are sales amount and order value? RAG does the similarity matching. It also tries to find out the words which are synonyms to the words which are there in the query. But in case it fails to find the synonyms, to understand that sales amount and order value can replace the total revenue column that it is looking for, in that case, it will miss on the important columns, and the SQL query generated will not be correct. Along with this, RAG also does not have a very good understanding of how the tables are joined. So let's say if there is no direct connection between, let's say in the query, we want these tables, customer orders and payment, and there is no direct connection between customer and payment table. In that case, RAG will not be able to identify that how can we join these three tables. So this is where there are some issues with this approach only. And at this point, we are able to understand that RAG alone may not work. RAG is a good approach. RAG is a good approach to reduce the search space, but we need something more in order to make sure that in cases of complex queries, all the relevant tables and columns are selected. Because in a SQL query, the most important step is to select the relevant tables and columns. Everything else is rules and structure and every other thing, but the most relevant thing is to select the right tables and columns. This is where we'll focus more on. So we understood that RAG alone is not enough. Now what else we can do? So what we did is, we had a database schema, as we can see in the left side, where we had table description, column description, etc. What we thought of is that what if we take the columns. Now if we notice here, the columns are represented as table name.column. If we take all the columns, which will anyway, they will have their table names, and we try to group them. We try to cluster the related similar columns in one cluster. So depending on what the example that I gave, let's say if they based on the columns, I have a cluster, demographic cluster. This cluster, it includes name, age, gender, location, information of the customers. Another cluster, I may have a financial cluster. It can have how much they ordered, the payment, the credit score, etc. So this is how, if we cluster the columns into some clusters, by doing that, we will be able to have some groups of columns. So in this case, whenever a query comes, if we identify that to which cluster this query belongs to, that will also help us in reducing a bit of search space. Now, there can be more issues in this approach also, that let's say if we have very huge database. So all this cluster, they include hundreds of columns. Which again, if in the query, if you have selected 3-4 cluster, your column numbers will shoot up, and again, the token problem will arise. So in order to avoid that problem, we did another level of clustering. so that we can create cluster among those clusters. Let's say I have a demographic cluster, I created more cluster in that demographic cluster. The subclusters can be personal information, location information. So all the personal information related columns will go into the first subcluster, then location information related column will go into the second subcluster. These are just the ways by which we can reduce the search space, and we also make sure that whatever is being left by RAG can be picked up in this process. So this is what we have integrated with RAG in order to get all the important tables and columns. Okay, so one problem is solved. There was another problem that we saw when we were discussing the limitations of RAG. That how to join, how to know that how different tables they are joined. So in order to achieve that, in order to solve that problem, we use knowledge graphs. Knowledge graphs, they are a structured representation of data where we represent data in the form of nodes and arrows. Nodes, they include the table and column names, and arrow, they mention the relationships. So those three tables that we discussed earlier, customer, orders, and payments, we have represented them here in knowledge graph. And we can see clearly that how the tables customer and payments are related. So first of all, they are not related directly. There is a relation between customer and orders using customer ID, and orders and payment using order ID. So this is how we need to join these two tables in the query, if we are using these two tables. So now our join problem is also solved. Now we'll see the complete architecture, the complete picture of the solution that we developed. So let's say there is a user query. The user query is show me the total revenue from customers aged 25 to 35 in the last quarter. What we did as just think of it as a human being. If we are given that we have to write a SQL query for this query, what we will do? We will see that what are the tables and columns which will be relevant for this query. So first we will see that total revenue. We'll see that what can be the columns and tables related to that will be relevant for this to calculate total revenue. Then we will see that, okay, customers age 25 to 35. Now we need to find the age column. Then we will see, okay, they are talking about last quarter, so let me see the time related columns and tables. So similarly here also, we splitted the query. We splitted the query into sub-queries. So in this example, the split query will be, one sub-query will have total revenue. Another sub-query, they will include customers age 25 to 35, and another sub-query, they will be taking the time-related information. Now we have sub-queries which include different columns. Now, which include different metrics or the keywords that are there in the query. We have given this sub-query to RAG in order to retrieve the relevant tables and columns. Parallelly, we have also given these sub-queries for cluster mapping, to map first some high-level clusters with these sub-queries. So the first sub-query that is about total revenue, it will be matched to the financial information cluster. Then the customer aged will also be matched to the it will be matched with the demographic information cluster. Then after the cluster mapping will happen, high-level cluster mapping based on, so we have demographic cluster and financial cluster. Now in the next step, we will only take the sub-clusters of these clusters, and then we will try to map again these sub-queries with those second-level clusters. Now in the next step, the total revenue column, it will match to one of the sub-cluster in the financial information cluster, and the customer aged column will be matched to the personal information cluster of demographic cluster. So I know like a lot of clustering happening, but just the two level of cluster, one mapping with the high level cluster, then forgetting all the other things that are there, focusing on only high level cluster and then trying to map the same query with the sub-clusters of those high level clusters. Once you are done, you will get all these sub-clusters that were selected in mapping. There will be some columns associated with those sub-clusters. We will fetch those sub-columns. Similarly, RAG will give some columns which will be related to those sub-queries. We will combine all the columns that we have generated from these two processes. Now there will be a lot of similar columns from both the processes. We will deduplicate. We will only have unique columns which are there from both the approaches. Now we have the selected columns. We will give these columns and tables to LLM. We'll ask it to, and along with that, we will also give the user query. We will ask LLM that now you have this space. Now in this space, try to find the relevant columns and tables for this user query. Now having the less space, LLM will be able to identify and then it will select the relevant tables and columns. Once this is done, now for the join information, we will give the tables that we have selected and we will try to fetch information. We'll try to fetch how these tables are joined from knowledge graph. We will now have the join relation also. We will combine both these and then we will give it to LLM to create the SQL query. This is the complete solution where we have taken a hybrid approach. We have integrated hierarchical clustering along with RAG to get the tables and knowledge graph to get the join information. Now, as a very important step in any solution, we want to benchmark and we want to evaluate how our solution is performing, what we have done is correct, and if there is a chance for improvement. So in order to do the same here, actually like benchmarking SQL query generation, it's a bit tricky process because you are not having just numbers, you are having SQL queries. So there are some open data sets which have user queries and expert have written SQL queries for those user queries. So we have taken one of those open data set. There's a spider data set. We took one of the data set and for the same user queries, those are there in the data set. We tried converting them into SQL using our solution and then tried comparing the solution, text to SQL solution that we have generated, the queries generated from them and the ground truth query that were there in the data set. And then we saw that, so we tried benchmarking it at different level. First we saw that the columns which are selected by the ground truth SQL query, are they same as the column selected by our solution SQL queries? Then we saw the tables are the same. And then we executed both these queries into the database and tried comparing the results, if the results are the same or not. So this is how we evaluated it. So it was performing very well with the small and medium level query. The accuracy is more than 96%. But for the complex queries, it is still in the process. It is more than 90 and lesser than 95. And we are working on it to improve the solution. Thank you. That's about text-to-SQL. Yeah, so it's a way of representing your database. So let's say if you will represent in the tables and columns format, then trying to understand that how these tables and columns are related, it will take us some time. If you will represent in the graphical way, then to get to know that how these tables are related, it will be easier.
How do you pass that information to the LLM? Because you can only...
Yeah, you can store it in the memory, and from the memory you will fetch that what are the tables which you want, and then the join relation between them.
I'm not familiar with this because the way I see it is, okay, you can give text input or you can attach files. How are you attaching this knowledge graph?
If you want to store this knowledge graph, you can also store in the pickle file.
Okay.
Yeah.
Thank you.
Thank you. Yeah.
Is the LLM, text LLM able to understand that, or you need to use some VLLM to pass it as an image and understand?
Since it's only the text information, they are clearly telling like how the tables are related. so they are able to understand.
And one thing you mentioned, complex query, it was below 90, right?
Can you please speak aloud?
Yeah, for complex query you mentioned, right? For a large database, the accuracy is less than 90.
Yes, yes.
Can you provide any detailed example?
Yeah, so actually we are working on improving the solution. So we have solved selecting the relevant columns and table problem, but there are other problems. Let's say as a user, since I don't have information about the table, I have asked a query like what are the total sale in US. But in your table, there is nothing called as US, you have United States. So in those type of problem, LLM doesn't know, and you are not also giving the values in the database schema, because there are a lot of columns and tables with having a lot of values, lot of unique values. So for that, we are actually working on a data profiling method where after the table and column are selected, what we are doing is we are just then for only for those columns we are trying to get the unique values, and then we are using that, giving it to LLM, saying that use this for any keywords if they are there. So it's in the process.
Yeah. Hello.
How you have built the racks actually using your enterprise database schemas? Because that should not be exposed to the external world. Have you used the internal rack or enterprise rack or?
Yeah, we use Milvus.
Which one?
Milvus.
Milvus.
Yeah.
Okay. And do you have anything experimented like I don't want to expose the complete database to the LLM?
Yeah, yeah.
Okay. But I will give a sample of rows for learning purpose. Okay, like whatever you said, like country is there,
Yeah.
or some region is there where it will be like Chicago is CO or USA is US something.
Yes,
which is
yes.
represented. So I will give a sample data set and it will learn from that, and then it can take over with the actual database.
Yeah. Yeah, you can do that. So this is what you're talking about, fine tuning. If you want to fine tune the pre-existing LLMs using your data, for that you need to create the data in order to for it to fine tune. So you need to maybe create some questions and answers so that it can learn that what are the keywords which are there in your data.
Yeah. So you talked about like dividing the main query into subqueries and then running the clustering and RAG pipeline.
Yeah.
So before giving to the LLM for selecting the columns, you are just combining and cramming all that subqueries results, right?
Yes, yes.
So do you apply like re-ranking and stuff also, because RAG does not always give the most relevant tables, right?
No, because we do not want to miss out on any columns.
Okay.
So we are not applying any re-ranking. We are giving it just as it is.
And RAG gives you the similar tables, the connected tables for the selected tables, right?
Yes, yes.
Got it. Thank you.
Hi. So how does the latency compare between running a normal query and going through all the process of embedding, vector search and LLM?
Yeah, so actually like when we just use normal LLM, then the database size was so much that we understood that this is not the way to proceed. So we didn't check on the latency. We understood that it is taking some time, and for more, when the database size was increasing a lot, then we were not even able to run it, and it was also not giving the correct queries. So we didn't take it as a baseline to compare the latency. Yeah. Thank you.
Hi.
Yeah.
There was a one step that you introduced, mapping to a clusters or
Yes.
subclusters.
Yes.
How is that happening? I mean, is it a manual logic we have to write it? Or
No, using LLMs only. Because
only.
we don't know like what can be the clusters. It changes depending on the databases, right?
okay, we're basically going through LLM multiple times.
Yes, yes.
Okay, got it.
Is this better than that approach, or what's your take on it?
No, we have not tried that particular agent. But have you seen like is it performing well on complex queries and when your database size is increasing?
Yes, it is performing well. The query is pretty good, but the cost is too much because too much token in out and a lot of back and forth between the DB schema, because LLM has to understand the DB schema. I see SQL agent is creating the query not in one go. It kind of does it in an iterative way.
Yeah.
So too many back and forths, and hence the cost is increasing. And hence the delay is also there. So we are trying to fine tune it with caching, RAG, and whatnot.
Okay.
But I'm just trying to understand if probably this would be a better solution there.
Yeah, so actually the back and forth part is not here. So maybe you can try this and see.
Yep.
And we'll also
Thanks.
see.
Yep.
With the bind variables, if you query,
Yeah.
like if you give a number range,
Hmm.
how it is going to address that one?
So LLMs, they are smart enough to understand that it is from 25 to 35. So when it is creating the query into subqueries, it is also adding the description that what can be the total revenue mean, what can be the customer aged between 25 to 35 they can mean, and what the last quarter it means. So in that way, they have the context that the range is from 25 to 35.
Is there a learning needed for that also?
No, they understand this. They are very good at understanding English. It's just that they are not able to, they are not very technically sound to come up with large complex queries.
Hi Akriti, this is
Yeah, hi.
Hemant.
Hi.
Good session, thank you. A question that whatever queries you get from the LLM, do you feed directly them to your database? Or do you have the human intervention in between?
Yeah, so we are this system, it is directly sending it to the database. But it is like one of the future steps that we want to include. We want to have a UI that in that, like if we give a query, it tells us that this is the SQL query that we have come up with, and once the user approves it, we can execute. But this is in the process. It is not yet.
Because the question was more on the fact that suppose you get drop database command into your query, right? You can't directly feed that. You can't directly feed that into your system because it will delete all your database, right? So
yeah,
did that kind of thing happen in your setup so far?
No, because there was nothing to delete. But yeah, I mean, we are adding on the human feedback for various reasons. Yeah.